Calculus is algebra with additional logic and algorithms designed for computing incomputable quantities. The primary difference between calculus and algebra is the concept of infinity. In calculus, infinity is considered a concept, not a number, and therefore cannot be used in any arithmetic operation, such as addition or subtraction, etc. Also, a variable is never equal to infinity. Rather, infinity is a limit that may be approached but never reached. It is our first example of an incomputable quantity. To deal with incomputable quantities, we use the concept of a limit. A limit is a value that a variable approaches or gets infinitely close to. Usually, when we talk about limits, we talk about what happens to a function as a certain variable in it approaches a limit. For example, the limit of the function 1 over x as x approaches infinity is 0, because as x gets infinitely close to infinity, the function gets infinitely close to 0. The limit of a function as the independent variable approaches positive or negative infinity is called end behavior. Limits are most often used for describing parts of graphs that do not exist, as these are otherwise incomputable quantities. But a limit may also describe a part of a graph that does exist. In fact, by definition, if a function f is continuous at a point a, then the limit of the f of x as x approaches a is the f of a. In order for a limit to exist at a point, the function must approach the same point from both sides. For example, the limit of this function as x approaches a does not exist, because the limit of the f of x as x approaches a from the positive side does not equal the limit of the f of x as x approaches a from the negative side. If the limit were to exist, the graph would have to look something like this or this. In either of these cases, the graph is going towards the same point in both directions, and therefore the limit does exist.
That was delightful.